The current geopolitical situation has brought us more closer as allies. We're sharing more information. We're more open about what information we share with our allies. We're not afraid to give away our weaknesses to our allies, of course. So this is where we learn and become stronger. And with this, I would like to also introduce our first speaker of today. This is Wayne Burke, and he's joining us remotely from North America. And he's an expert, a widely recognized expert in international level. And his focus is defensive and offensive AI and drones. Yesterday, he was giving also the workshop on introduction to the drone forensics. With this, I will turn over to Wayne. With an applause, a slight applause, we bring him online.
Hey, good morning and welcome, ladies and gentlemen. Thank you so much for coming to the conference. Thank you so much to cert.lv, for BB, and everybody who's really pulled off amazing feats to make this happen. We're going to be talking about drone tactics, forensics, and incident response. So, without further ado, let's jump into our topics. I'm not going to spend much time on my background. I come from a law enforcement background. And really, the transition to cybersecurity was a natural progression, especially when you're looking at, investigations, right? But I've been shot, stabbed. I've seen the world maybe a little bit different to many of you folks because I've had many near-death experiences. Now, you might hear the accent is not South African. It's a mixture between South Africa, Britain, and the United States. Those are pretty much the regions where I've grown up. And today's agenda, we're going to be talking about commercial off-the-shelf drones. We're going to take a technical deep dive into all sorts of different components that make up your UAV or drone ecosystems, from sensors, flight controllers. We'll be speaking a bit about radio frequency, communications, and then I'm going to take you through DJI-4 Phantom teardown, where we want to look at all the different components that we are going to be expected to gather and extract and acquire forensic evidence. I'm going to cover a couple of hands-on demos, although I'm not going to be doing them hands-on live. I'm going to talk through them because, the demo gods, when it comes to doing live demos with Linux and drones and drivers and all of those wonderful things, it's not always perfect. So we will look at digital forensics, incident response specifically for drones. We'll look at using certain open source tools so that when we learn with the open source tools, that will give us the ability to use any tool, whatever commercial, developers created. And then we're going to look at some of the other tools that make our job a little bit easier. So we'll start off with some news, right? This is latest news from September 10th. Ukraine joins NATO for a counter-drone exercise for the first time. So this is where we could see more than 60 counter-drone systems and technologies, such as these different types of sensors, drone-on-drone systems, jammers, cyber interceptors. Those were actually tested live. So it really means that we evolve in whilst we test in the capabilities and the technology that can help us defend in this completely crazy geopolitical current global situation I think we all find ourselves in. So NATO explores new drone technology as Pandora's box opened in the Russia's war in Ukraine, of course. So we can see these were from the recent exercise that NATO held. And the key point here, they are constantly in the sky. They monitor territory along the front line, like 20 kilometers in depth. And this is where the biggest threat was the intelligence, surveillance, and reconnaissance drones, which obviously were used for surveillance. And this is, again, if somebody now takes that knowledge and decides to really attack some civilian object in Europe, as an example, with those types of first-person view drones, it would be extremely difficult to defend. And that's from Ukraine's Innovation Center at the Ministry of Defense. So I aim to bring you knowledge that's going to potentially help you to see the future, to see what things you might need to be focused more on. And this is a game where we can see it's a constant cat and mouse game, right? So this is Russia has a secret war drone project in China. and we can see some of the wonderful images from these looking crafts that don't look like normal quadcopters. Obviously, you got various different form factors when we generically use the term drones. We got quadcopters, we got fixed wings, we got all sorts of different form factors. And for those of you folks that really want to get into building your skills when it comes to digital forensics, I'm not connected to TryHackMe in any way, shape, or form, but you can get yourself a lot of free daily learning from TryHackMe, where you can actually do 1 hour of hands-on labs every day. That's one of the things that we need to be aware of. We've got to build our skills. Certifications are important, but really to do our job, we need to have the skills to do our job. So you can see there's a number of free rooms that you don't even have to have a paid subscription, and you can still participate for free for 1 hour every day, launching virtual machines, operating the cloud, going through hands-on learning. And this takes us straight into a quick deep dive. This is from a very old flight controller, and I really wanted just to give you a diagram that you can initially see the topology of. It's a flying computer system effectively, with batteries, with a lot of different radio frequency components, and a lot of electromagnetic interference, because there's 4 motors, or in a quadcopter 4 plus as an example configuration. You're going to have 4 motors. You're going to actually have more if you design it in different configurations, like an octocopter or a hexacopter. And we can see we can add a companion computer such as a Raspberry Pi. That's one of the reasons why we would need to add a battery elimination circuit to obviously regulate converting our LiPo battery power from, let's say, 7.4 volts down to 5 volts, so you can communicate with your companion computer. You might be integrating artificial intelligence as an example. And well, now we're going to give you the problem, right? We want to talk about the problems, but we want to talk about the solutions at the same time. So this was me flying reconnaissance out in Eastern European country. I won't confirm or deny, but you're going to see that this drone was targeted with a very high-powered ground launched laser, green laser, that was mounted on the ground. And let's take a look at this video. Now you're going to notice I kept pausing it like this on purpose, so you could literally see the surrounding area. And you're going to see some pretty good drone flying skills, flying very close to this statue. And I'm sure it won't take people very long to find out where I was actually flying this drone with our image recognition. But I wanted to fly close enough to the statue because I wanted to see what may be connected. There might be radio frequency, signals, antennas. And very shortly, you're going to see on the left-hand side of the screen, you're going to start seeing a flashing green light. And you're going to see the effects of why we need to learn forensics, because we're going to have these drones everywhere. There you can see the green laser starting to try and track, and then it's going to lock onto my drone. And then the next second, you're going to see the actual drone gimbal drop. So you can actually see the green laser affecting my drone in a pretty severe negative way. Now, you're also going to have other instances, right, where you might have drones that crash. So we don't realize if we don't fail 1,000 times, you're not going to succeed once. So this was way back more than 10 years ago of me building different types of drones. And you need to realize each motor is controlled by an electronic speed controller. And if you don't fine tune those electronic speed controllers, you're about to see what happens when you are without a finely tuned electronic speed controller. My one propeller at the back right-hand side was acting a little bit off, as you're going to see. So this was a pretty big DJI build. It's a big lift. It's got a lot of lifting power. As you can see, it's pretty large. I'm just testing. You can see the bottom right propeller just didn't look right. It started and it wasn't spinning like the other propellers were. I was figuring, let me just check to see what it looks like. Because, we want to go like, okay, I want to just take off now. So I'm looking at the stability, testing to see if the props are balanced. And I should have learned right there, right? I should have been like, okay, we need to go back and do some fine tuning. But when you build drones, you just want to get them up in the air and test flight, right? You want to fly them. You want to test how they fly. And so we can see props still look like they're spinning okay. But imagine this now, having a drone crash in public where somebody's going to get injured. You're going to have to figure out who was responsible for that accident. Was it the machine or the operator? And obviously, in a lot of countries, either way, you're going to be responsible to some extent. So the final part, I was like, okay, let's get this up. I gave a lot more thrust. So got it up in the air for a few seconds. I was all excited, and then all of a sudden, boom, crash. All right, so that's why we need to look at forensics. But of course, I came back with a rebuild, and this is just showing you a ground station. So this is with a new set of propellers, new motors, completely more professional motors, as you're about to see. It's so much smoother. And this is why we need to learn how to build things. Now, obviously, there was some kind of cable tie catching one of the props there, so I went to just go and readjust all of the things there. But this is something when we start looking at, drones nowadays, when we flying drones commercially, we're going to have our flight checklists. You're going to obviously be licensed in a lot of countries to fly drones commercially. And of course, you can see there's the two rails there that allows you to plug in different modules. And there we can see the propeller spinning a lot smoother, a lot quieter, and you're going to see the liftoff. Completely stable and smooth, beautiful. And of course, this is why we need to look at forensics. So we are seeing a huge amount of technology when we talk about a drone, but this is going to be a drone that looks like a bird, flies like a bird, and it's a robotic, autonomous vehicle. Now, the drone's controlled by his glove that he's wearing, the hand and the glove. The virtual reality, AI for the autonomous flight. All right, so you get the gist. That was sharing a little bit of why we need digital forensics. And I'm showing you the digital forensics analysis methodology from the US Department of Justice. And you can see the focus for us is to look at, the preparation, extraction, identification of evidence and artifacts, and then the actual analysis. Sure, you're going to have to acquire the image. We're going to be taking you through some examples, but this is the procedure, the method, the flow that we follow when collecting and analyzing our digital forensics. You can download the forensic examination of digital evidence, a guide for law enforcement. It really breaks it down into very chronological order, as you can see. And now we're going to start realizing that when we're looking at those commercial off-the-shelf drones, well, the DJIs, the Uniques, and so on, well, those generally have a lot more of the UART connectors, the FTDI, so you're going to be able to interface with electronics much more efficiently. But when we're dealing with drones that are not commercial off the shelf, drones that are potentially weaponized, we are going to have much more of a challenge to collect the forensic evidence because they're much more simplified. Some of these drones are developed just to give you first-person view, and it's going to be a non-return drone. It's going to be used to fly improvised explosives to its given target, and you're about to see what these drones look like. So much more simplified. And so what does that mean? Well, we need to ensure that we know how to collect the digital evidence to figure out where the actual threat came from. So when we're dealing with different types of drones, you're dealing with fixed wing, you're dealing with multiple configuration motors, as you can see from some of these diagrams. And then you're dealing with the very small, sometimes used for your reconnaissance missions. You can get a bunch, like specifically 63 drones with 25 different models from DJI, Parrot, Sensefly, Unique, Skydio, Reezy, Sky Viper, Ardu Pilot, and Aeon, however you want to pronounce it, where they have been sponsored by the National Institute of Standards and Technology. So you can subscribe to their Google Drive. They will obviously vet and validate that. So it was funded by the Department of Homeland Security, their Science and Technology Directorate. And you can then download all of the different forensic images for these commercial off-the-shelf drones. As I said to you, that's fine, but we also need to look at those non-commercial off-the-shelf drones that have been custom made. And so effectively they went out and they created all the different data sets for us. So you can see the general contents would be, there's pictures and videos that each of these drones have been flown in a way that they had flight data. So when you collected the forensic evidence, you are actually going through your full-blown triage of your UAV drone system. So not always just the drone, but the remote controls, the cell phones very often used to obviously manipulate the telemetry or your cameras, and then also your ground control stations that you're going to use to do pre-programmed flight pads. So for us, we're looking at specific types of data to retrieve, to try and figure out who, why, when, what. You're looking for serial numbers. You're looking for data that includes the flight path, so you know where it came from, where it was going to, the flight speed, the bearing, the launch and landing locations, obviously trying to find the actual pilot that may be piloting the drone, unless it's automated with AI, which is absolutely very popular and possible nowadays. You're looking for photos, videos, and then very, very specifically, depending on what login has been enabled on those commercial enterprise drones, you're looking at the log of actions the user made from the actual drone controller. So remember, when you're looking at forensic evidence, there's going to be machine generated evidence that's based upon the functional application as it's being used. So it generates forensic evidence. But when you do something as a specific user and you specifically delete a file as an example, that's going to record from the actions of the human operator. So forensic evidence from the actual technology and your forensic evidence of the actual operator. So this first demo, we're going to be showing you how to use open source forensic tools. Now remember, this is the part that I've come from a law enforcement background. A lot of military folks are using open source technologies nowadays because of the sheer fact that many other commercial technologies are just not secure enough. This is where we can use open source technology, where if we don't like something or we want something more, we can add that. So when it comes to autopsy, it's just an open source, extensible, and very fast entire framework for us to actually triage and pass our forensic evidence. So the first thing is we go and set up a new case. When we set up a new case, it's going to be setting up your database files, and then we're ready to go and select add in our forensic evidence or artifacts, where you're going to specify the location of where your evidence was from. Now remember, the quick reminder, you can take the forensic images that are readily available. You just have to subscribe and request access to the actual forensic images that have already been prepared. So we then select our data source. As you can see on the top left image, I'm selecting a disk image, or you could use a virtual machine file. And here we're using a standard raw DD raw image, as you can see. And now I can select my ingest modules. What this means is these are when you ingest the forensic evidence, it's going to process that evidence based upon these different modules that you can add third-party modules. you can custom build your own modules as well. And so you might well see that there's a DJI drone analyzer, which is based upon the demo of the forensic evidence that I'm adding. The forensic evidence that I'm adding is of the internal storage. So it's the internal SD card effectively. It's about 3.9 gig in size. So once you've finished letting that process, now we can actually start doing our actual triaging and start our analysis. Looking at information such as your GPS tracking, you're going to have certain encrypted, suspected artifacts that you may need to decrypt. And this is just giving you a quick overview without going into too much detail, because I'm going to be showing you additional tools and open source frameworks that can be used to speed up your triaging. So the next thing I want to talk about is a paper that's now focusing on your actual remote control. Because effectively, if you're not aware of this, a lot of the drone technology is effectively flying Android operating systems. So it's almost like a cell phone, but remember, Android is Linux, or Linux derivative, and it's open source. So in this paper, you're going to want to use certain types of firmware as an example for like a drone remote control. So this is a great website where you can freely download firmware for an array of different types of drones. Of course, DJI being very, very popular. It also supports the Autel aircrafts as well. And I'm sure in the future, they're going to continuously start adding more and more makes. Now, on the same slide, later on, you're going to see where you can actually do drone hacks. The drone hack means you're going to be able to lift the restrictions such as your non-flight zones. So your no-fly zones, you can actually remove those by essentially jailbreaking with custom firmware your actual drones. So this is, again, information I want to share with the whole community. So here we can actually see the different specific features of removing your NFZ removal, so your no-fly zones, your altitude limit removal, and then you can do a lot of firmware customization for law enforcement. This is a company based out in Slovakia, so based out in the European Union, and you can also start boosting your actual signal strength, allowing you to even fly further distances. Generally speaking, in the European Union, your maximum transmission is a lot less than United States. So this is a quick example where we're not going to watch the video, but they've got video demos of showing you how to actually do the actual jailbreaking. And for us, the actual focus is on evidence, right? So we're looking at how the remote control establishes connections with the different devices. So the little diagram you can see on the screen is where we're going to look to collect forensic evidence first. We can try and connect it through the remote control using the DJI Assistant 2 software that would then allow us to use a serial cable, a USB serial cable, plugging directly into the drone, where we can extract a whole bunch of information. But we're also able to look at actually accessing the specific external SD card, where you might have your multimedia files like pictures and videos and so on. And then also your flash memory, where you're going to have firmware files, system logs, your Android APKs, your applications, and then your application logs. So when we were looking at forensics, 10, 15 years ago, before we had all of these fancy Cellbrights and Oxygen Forensics and Elcom Softs and Encases, and of course the list goes on, this is where we want to do things manually. So using the Android ADB, your Android debug connection with your software developer kit, the very first thing you're going to do is check the flash's memory and the device names. So you're looking at your partitions. Then the second step, you're going to set the TCP port number, where you're going to actually be using Netcat to actually receive an image dump. It's going to take you some time based upon the speed of your network, but you're going to be imaging the flash memory and then essentially transferring that via your TCP port that you specify. And then the last step you can see there, step 4, you're going to receive the flash memory dump. That's going to be delivered by the DJI remote control via your TCP port that you actually specify. And once that's finished, you can see you will then be left with an IMG, an image file. So a list of some of the actual artifacts. You can see certain directories are encrypted. You can see a description, and there's a ton of information. This is directly all from that one article, that white paper, amazing in depth. And this next article, which is really by a young lady, she's originally from Japan, amazing. She's only 18 years old, and she's written an amazing application, or many actually projects, but we're going to be looking at her framework that will allow us to actually extract forensic evidence from DJI drones much more effectively. But generically speaking, your 9 phases of digital forensics, you start off with your first response. So you get called out, there's an issue, and you've got to look at your search and seizure. So you start doing your search and seizure. You want to look at your evidence collection, secure the evidence, perform your data acquisition, and then you're going to start doing some of your triage and your data analysis. Looking to do evidence assessment, so you can assess what evidence you already have and what could be used to prove or disprove guilt, your exculpatory or inculpatory. It all depends on which side of the fence you work in. And then finally, step 8, you're going to be looking to your documentation and reporting, and you may need to take that into criminal prosecution. So you may be the role of a witness. And that's essentially a teardown of all the different electronics. This is a picture of the Mavic Air 2. And as we see in the progression of this technology, keeps becoming more and more powerful, more and more advanced, more and more artificial intelligence, more neural compute sticks, as an example, or Movidius or NVIDIA, all of these neural compute technologies being injected into all of our technology. And so that means, sufficiently speaking, that when you start looking at all of our IoT, OT, critical infrastructure, drones, robotics, biomedical devices, yeah, they're very much using the standard STM32 chipsets. And so this is a diagram showing you how we're going to be needing to do more advanced either chip extraction or on the board forensic analysis based upon what we're obviously looking to prove or extract as far as evidence is concerned. And you can see this is a teardown schematic or diagram of your DJI Mini 2, showing you that you've got your DUML communication language, which you got various different protocols in your drone ecosystem, your GPS board, your gimbal, your camera board, your SD cards, your flight controller, your electronic speed controllers. All of those things have firmwares that you're going to look to potentially extract the firmware as evidence if they have maybe used a jailbroken or a hacked version of the flight controller. So they're not obviously limited by those no-fly zones and so on. You're going to have video, you're going to have your transceiver using OcuSync, depending on obviously what version drone you have, Wi-Fi, Bluetooth, and then your various different types of video encoding and collision avoidance. So your actual vision system. Well, I think we all remember what just happened recently with the exploding pages. So yes, those were loaded and laced with a couple of grams of highly explosive substances. Of course, nobody's going to confirm or deny some of those things. But generally speaking, when we start looking at batteries, lithium batteries, they are energy dense, like hydrogen, gasoline, or TNT explosive substances. They can release energy quickly, but not normally making a big boom. You will generally see that they'll start the igniting of a fire, and it's not always necessarily going to make a boom. In the case of the pages, well, I think it's not clear yet because it's not validated by any one party as yet, but it's pretty clear that even with 2 or 3 grams of shaped explosives that could have been hidden in the batteries. So this is where we've got to look at our actual supply chains, folks, because it's only going to get worse. All right, and this takes us to next, our DJI Phantom 4 teardown, where we want to look at being able to effectively collect the forensic evidence, but also at the same time, I'm going to be briefing you on this Chinese researcher did a great job of literally reverse engineering the hardware and the software to enable them to gain full access, because it's the same as a cell phone, right? When you want to access your cell phone as a root account, you need to look at jailbreaking or rooting your Apple or Android devices. Essentially, when you look at what that jailbreaking or rooting is it's a Linux file system. It's a Linux operating system. So you're looking at copying your super user binary file to the system partition so you can actually call up super root privileges, right? So you're going to have a root privilege on those devices. So starting off with the DJI architecture, the first inter-module communication, you can see 2 bytes represent the communication source address and destination address. So the example there is 03 represents the flight control, whilst your 06 represents the sticks sub function, which really is giving you different types of communication methods. You've got local, IP, UART, I2C, SPI, CAN bus, ADB. So there's an array of different types of communication protocols. Now, some of you might be going like, wait a second, isn't CAN buses used for motor vehicles? That is absolutely correct. Same as ADB is used for your Android debug bridge. So you have your communication protocols such as your Mavlink, your NAL, your V1, V0, and then your just general logic, depending on if it's proprietary types of protocols. So again, looking now more specifically at the actual hexadecimal forensic evidence, where you're going to need to be able to prove that the operator of that drone was doing nefarious things if they were, let's say, injuring people in a civilian gathering, as an example. So up next, we have the actual motherboard, and you can see the different chips. So that's a Movidius. That was a Movidius Intel Neural Compute Stick for your AI, your vision system, and you can actually see the very specific make and manufacture of those chips. Your memory and storage, it's your Samsung, your eMMC, your DRAM, 4 gig built in, and that's where we looked at it earlier on, acquiring either the local SD card image. Normally you're going to have your flight logs and you're going to have a whole lot of your machine forensic artifacts. So it all depends on the more expensive drones will have much greater storage and higher end components, whilst naturally the cheaper drones won't have as much complexity. So our objective is to be able to gain root access. In this case, we're using ADB to assist. So basically, we're going to be rooting your Android OS, so we can then get full access to the file system that includes even the encrypted components and the encrypted directories. Now, you'll remember earlier on, I was actually showing you a breakdown of the general artifacts, and there's a lot of artifacts that are encrypted. So we don't really have a choice. If we want to collect all of our forensic evidence, we're going to need to gain root level access. And we're using this bash script to basically achieve the root access. It's a relatively common method for rooting. It's going to need both software and hardware modifications. And obviously for us, our goal is to access the contents of memory, and more specifically, some of the actual artifacts that have been encrypted. So you can see a lot is to be done next, because we've got to use a heat gun to actually extract the chip off of the actual main board. So we're going to use an eMMC card reader. You can see the little image there. There's a lot more ingenuity nowadays, making it much easier for us to do chip off forensic investigations. So we need to locate the appropriate partition where our artifacts of interest are stored. We'll mount the file system partition using ext4, and then we'll look to modify the actual script we used so we can write the system image back to a raw data file without all of the encryption. So we'll simply use the same eMMC card reader to use a blank chip to write that back to, and then we can actually solder that back onto the actual chip socket. And of course, this is very, very, very time consuming. However, once your job succeeded, you're going to have achieved root level access. As you can see, this is essentially what you're going to find when you've been able to obviously gain access to any device that is pretty much using Android operating system elements. Now, we mentioned Android operating system. So the most pure form of Android OS is normally when it's running on a Google Pixel device, because the Google Pixel device is manufactured through or with Google, and therefore it doesn't have as many additional third-party vendor-specific add-ons. So a lot of the other hardware vendors will basically use a very similar version, but they're going to have a lot more overlays specifically connecting to their architecture and the technology that they've chosen to use. Now, another very, very important element within drones is looking at your actual flight controller. In this case, our flight controller, we're using an Atmel chip. We're using a U-Blocks chip for your GPS. So you can see there we got our inertial measurement unit, which is your gyroscope and accelerometer. You've got a specific barometer chip. You've got your U-Blocks GPS module. You've got your double IST8310 compass module, and then your smart power, and then your electronic speed controller subsystem. This is pretty much what makes up your heart core architecture within your drone, right? That's like your central processing unit to a computer system. This is our flight controller. And then the next very, very critical and crucial part, as you can see, there's many different boards. This is from a Phantom 4, so a much bigger drone, where it's got pretty deep detail of vision processing. So you've got front, rear, bottom obstacle detection and distance measurements. You've got recognition of people, posture, water, region of interest. You've got infrared stereo obstacle avoidance, and then you've got your left and right infrared recognition. You've even got ultrasonic. So very often you will actually hold the drone up to your ear and you will hear the ultrasonic, the tick, 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 tick. It's making that ultrasonic sound. And obviously that's for detecting obstacles below the drone. So this is a very complex system that's going to hold a huge amount of forensic evidence based upon what the actual flight pilot was actually doing with the system. And then that brings us to our final part of the drone makeup system, which is where we haven't covered the ground control station, which is generally software / hardware to help you pre-program flight paths and missions and so forth. So you can actually see your architecture here for your remote control as well as your actual aircraft. And we can see as this is broken down, we're using OFDM wideband transmission for the modulation. We're using 1 megahertz and 10 megahertz bandwidth. You're using different types of channels for your remote control versus your air, your transceivers, your data control channels, supporting your frequency hopping, of course. And of course, it depends on the age of those drones, but very often you're going to be running 2.4 gigahertz as well as 5.8 gigahertz. I'm just double checking. Yeah. So I've got a couple of minutes left to go. We almost threw a whole bunch of content here. And so this was where we now need to realize when we want to look at the communication system, if we want to take over these different types of UAV, drones, quadcopters, you name it, we need to spend a lot of time focusing on the radio frequency. And so this is a deep dive that is actually showing you the pair and link. So when you set up your drone with a new remote control, you're going to have to pair that remote controller to the actual drone. So it's using, as I mentioned, your frequency hopping. It's generated based upon the actual serial number and ID of the remote control. And we can actually see the actual RC initialization here using your NXP chip. So it initializes the baseband SPI registers. It then initializes your transceiver SPI registers. And then it starts to do its broadcasting with fixed frequency hopping. And the same happens on the drone itself. So for us, you can see the right the 5-byte pairing code to the baseband SPI address. For us, we want to be able to take note of that because essentially we're going to be looking to take over control of this drone. So when we're looking at the actual RC frequency hopping cycle settings, we want to be aware of that so that we can try and intercept and manipulate the actual data and then take full control of that drone. So as I mentioned, the air pairing is what's going to normally pair your remote control to the actual drone. So you're not going to have somebody who's got another remote control automatically take over. Obviously, for us, we're going to have to look at collecting the forensic evidence to see, well, maybe that commercial drone was flying over a music concert venue, as an example, or it was simply delivering packages like Amazon packages in the US, as an example, to its destination. And somebody would have figured out that they could hack the drone and obviously get those drones to be used as weapons. We're going to have to go and collect the forensic evidence. And that's the key for us. Cracking the code for a full takeover, the process is really simple, right? Modify the RC firmware that's going to better enable the baseband SPI pairing code register at a fixed frequency point, perhaps every 10 milliseconds. That will enable you to replay the fixed frequency point air signal every 10 milliseconds through the use of a software-defined radio. And then you're going to be looking specifically to read the values from the baseband SPI registers. Take note, when we're looking at how this could be cracked and taken over, we're going to be looking very, very specifically at those digital forensic artifacts. So we can then write the results to the serial port. The cracking must be done offline and cannot be performed in real time. So theoretical conservative estimate in cracking that without supercomputers is about 46 hours. However, once cracked, the pairing code of the drone can be remotely modified and full control of the drone can be taken. So it sounds like it's an easy task, but it really isn't. The last couple of minutes, you're going to see there's a bunch of tools. We will be sharing the slides with you folks. So this is some of the GitHub tools. I pointed out the firmware download and then doing firmware analysis. This is showing you Ember. It's an open source firmware analysis framework that I incorporated ChatGPT API use with this. It took 8 hours to do the firmware analysis and cost me $20 in tokens for ChatGPT. But essentially, as you can see, it's going to take a lot less of your time than when you're spending $20 to do your deep firmware analysis. So you can see it's showing you that the OpenAI API key's been loaded. And essentially, once it's finished the 8 hours and 35 minutes in this case, I was given an array of different types of CVEs to go and look at because there may be weaknesses within. It's a flying drone, right? That's based on Android for the most part, in a lot of drone manufacturers at least. So this has cut down a lot of your firmware reverse engineering analysis into a much more efficient way of doing your reconnaissance. And then the last tool here is the DJI triage tool. So this young girl, she's 18 years of age. This can be installed very, very quickly. It's developed in Golang, so it's much more memory controllable through the programming language itself. And so once you've installed this with 3 syntaxes, 3 commands, you're going to be able to do your DJI file parsing. You're going to be able to extract steganography content. You're going to be able to visualize your telemetry, your flight and integrity analysis. You can see those are the 3 steps to build from source. As long as you've got Golang or Go installed, it will be pretty easy. And then the final part there is to show you how you can actually use some of the third-party tools like air data usage for your flight data analysis. And then finally, there's a lot of artifacts in the test data directory to help you obviously get used to using the actual tool. So in summary, we covered a whole bunch in 45 minutes. I'm not going to speak much about what we've just covered. I will just say, once again, thank you so much for inviting me to speak. Thanks for the cert.lv, for all of the people that have been participating to make this event so successful. BB, awesome. every step of the way. He was there day and night, 24/7. It was an honor and a pleasure, folks, to be presenting this to you. And perfect, spot on time. We wish you a wonderful lunch break, a wonderful rest of the next afternoon set of session speakers, and a wonderful day tomorrow. Thank you so much, ladies and gentlemen, for listening to me and sharing your time with me.
Thank you. With a round of applause. I would like to still ask you one question before you go. Maybe it's a set of a few questions together. I think it's a question because you were mostly focusing on the commercial off-the-shelf DJI drones. In your experience, because you've experienced more also custom-made drones, how would the forensic approach differ when you are reaching out and analyzing the custom-made drones? In addition, what tools apply from what you have done? And also, for me personally, is there a defense mechanisms that you might see that are implemented on the custom drones by the operators, either cyber or physical, like destruction of the drones, or not recording log files? So this is pretty much a longer question.
Yeah, so I'll start off with the first thing is the commercial off-the-shelf drones. There's a lot of custom tools that are available, like the Cellbrite, the oxygen forensics, but it's the custom drones that we're going to be more concerned with because terrorists may be using them, obviously military use. So they are using a number of different types of defenses. So you're not just going to be able to get to the actual firmware. They're going to be using very protected firmware, locking everything up so you cannot get to their actual system. You're not just going to be using your standard Elcom soft or your FTK or your Ncase. You're going to have to use good old-fashioned Linux open source tools that are generally hex editors. So you're going to be diving deep into extracting the actual chip from the devices, obviously where feasible. And so in my experience, it's only going to get worse. And the reason why it's only going to get worse is because we are building our own drones, so we don't have all of those commercial limitations. Like I said to you, I've removed the cover off of this drone, but you essentially got the same components, except the actual open source builder can lock up those components, making it a lot harder to actually get to any of the digital forensic artifacts.
And protection of the drones, the destruction of the drones. You need to be careful when approaching custom drones, right? Maybe they can explode, or have you encountered that?
Yeah, absolutely. So we can pull off enough videos on YouTube to see how some of the folks in the Russia and Ukrainian offense have been responding to those. But yes, absolutely, you're going to be very careful because very often those are booby trapped. So if you just go and pick it up, they might have a trip switch. There's all sorts of improvised explosives that are being used. And of course, as we figure out one style, so 3 other techniques and 3 other methods start coming out. You may have seen the new attack technique is literally a golden rain because it's using a huge box of compressed thermite and literally just flying over, which is why it's called golden rain. So make sure you keep yourselves safe at first. When in doubt, chicken out. You folks are very near to the conflict, so you might get some stray targets drop off over in Latvia, and that's the part where you've got enough qualified personnel from the cert.lv to assist you with that. But honestly, folks, if any of you want to connect with me, we do a lot of military-based training for special operations, so I'm happy to connect and communicate with any of you folks. I want to offer a lot of my time because this offense is going to get worse, and we can globally get together and work collaboratively to obviously take care of these global geopolitical threats as a team of global experts.
All right.
So once again, thanks so much.
Thank you again. Thank you, Wayne. And of course, because this is a technical track, and this is more hands-on, deep dive, demos first, this is why we sacrifice to the demo gods a few keyboards and memory chips in the server room during nighttime. And with this, I also welcome on stage Richard. We still have a few minutes to give to Richard for connection, at least 2-3 minutes, and then we will start.